Hey, Math 10C, Mrs. Ricks here. We're going to go through lesson 2.6, applying the trigonomic ratios. So solving a triangle means to determine the measures of the angles and the lengths of all the sides in the triangle. So basically what we're doing is we are just figuring out every missing side and every missing angle in the triangle. And number 2 here, we can use any of the 3 trigonomic ratios to do this. So the 3 trigonomic ratios, just to review, are sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. And tan theta is equal to opposite over adjacent. So this is where we get, and maybe you've heard this before, this is where we get what we call SOHCAHTOA. Okay, so SOH, so S stands for sine, O is opposite, H is hypotenuse, Ka, C is for cos, A is for adjacent, H is for hypotenuse, and TOA, T is for tan, O is for opposite, A is for adjacent. Okay, so just to go through those again, S stands for sine, O stands for opposite, and H stands for hypotenuse. So just to remind yourself that when you want to use sine, you need O and H, the opposite side and the hypotenuse side. When you look at Ka, so C stands for cos, A stands for adjacent, and H stands for hypotenuse. So again, to remind yourself, when you want to use cos, you need A and H, adjacent and hypotenuse. And T stands for tan, O stands for opposite, and A stands for adjacent. So again, to remind yourself, when you want to use the tan ratio, you need O and A, which is opposite over adjacent. Okay, so let's try this first example. Example 1, solving a right triangle given 2 sides. So we just want to, when it says solve, it just means to find out every missing side and every missing angle in the triangle. So let's do that. Solve triangle XYZ. Give the measures to the nearest tenth. So the first thing, let's find out that third side. Okay, so we're going to use the Pythagorean theorem. Pythagorean theorem says a squared plus b squared is equal to c squared. A and B are the legs of the triangle, and C is always the hypotenuse of the triangle. Excuse me. So I'm going to use 6 is a squared plus 10 squared is equal to c squared. Excuse me. So that's 36 plus 100, that's 136 is equal to c squared. To solve for c, we do the opposite of squaring, which is square rooting. Okay, so in our calculator, we take the square root of 136, which is 11.7, because it says the nearest tenth, so that's 1 decimal place, so that's c. So we have the one missing side that now we know. Now we want to find out our angle, so I'm going to use a different color. And let's find out what one of our angles. Let's look for angle X here. So angle X, across from that angle is my opposite side, and beside that angle is my adjacent side. So I'm going to use O and A, which is tan, opposite over adjacent. So that's tan of my angle, which I don't know, is equal to my opposite side, which is 10, divided by my adjacent side, which is 6. Okay, remember, in our calculators, we need to use the inverse there. So that means it's second tan, and that will give me what my angle is. So second tan, 10 divided by 6, that gives me 59.0 degrees. And this is, I have it as angle theta, but that is also angle X. Okay, now I'm looking for angle Z. So again, I'll use a different color here. Angle Z. Now angle Z, I know that the angles of a triangle have to add to 180, and I know this is 90, this is 59, so I can just subtract them from 180 degrees. So 180 minus 90 minus 59, and that gives me 31 degrees. Okay, so that is angle Z. So those are my 3 missing parts. That's how I solve this triangle, is just by finding the missing side and the 2 missing angles. So I'm going to get you to try B on your own, solve the triangle, give the measures to the nearest tenth. And let's try example 2. Solving a right triangle given one side and one acute angle. So solve the following triangle. Again, don't let that word scare you. All it means is to find all the missing sides, all the missing angles. So nice when they give you 2 angles because it's really easy to find the other angle. Let's look for angle D. We know that the angles of a triangle add to 180. So I'm going to take 180, I'm going to subtract 90 because I know that that's a 90-degree angle. And I'm going to subtract 25 because they're giving me that 25-degree angle. So 180 minus 90 minus 25, 65 degrees. So angle E is 65 degrees. All right, now I want to find out my side length. So I need side length F to E and D to E. So I'm going to use a different color here, and we're going to go F to E. So let's find this side here, F to E. All right, so I'm given this angle, so I'm going to use that angle. Across from that angle is my opposite side. Beside that angle is my adjacent side. So if I go back up to my trigonomic ratios and I check which one uses O and A, opposite and adjacent, that is tan. Okay, so I'm going to use tan to find out what this F to E side is. So tan 25 is equal to my opposite side, which is 5, divided by F E, which is my adjacent side. Okay, remember, when we are solving, we cross multiply and divide. So I make the one side into a ratio, cross multiply, divide by what's left over. So that's 5 times 1, divide by tan 25. So in our calculator, remember, it looks like this. 5 times 1, divide by tan 25. And that will give me the side FE. So we should get 10.7, we'll round it to the nearest tenth, is equal to side FE. Awesome. Okay, so now I have 2 sides. Now I want to find that other side. So you can use a trigonomic ratio or you can use Pythagorean theorem, whichever you prefer. Let's use Pythagorean theorem. So I'm going to use a different color again. So this is my side A, this is my side B. C is always the hypotenuse. So we're going to do A squared plus B squared is equal to C squared. So A is equal to 5. So 5 squared plus B, which I know now is 10.7 squared, is equal to C squared. So you can put it in your calculator just like that. You're going to get 139.49 is equal to C squared. Now, the opposite of squaring is square rooting. So I'm going to square root both sides. And I get 11.8 is equal to C. So that is my third length. So I have 11.8. I have 10.7 for my other side, and I have E is 65 degrees. So just be careful, your hypotenuse should always be the biggest side. So my side C, 11.8, it is bigger than 10.7 and 5, which is something that we should be checking on. All right, I'll do one more with you. Example B, solve the triangle below and give all measures to the nearest tenth. Okay. So again, I'm given 2 angles, so that's really easy for me to find angle J here. Okay, I'm going to do 180 minus 39 minus 90. That will give me angle J. 51 degrees. Okay, and now I'm going to find, let's go for this side length here. So my opposite, I'm going to use tan again, and adjacent. So tan of my angle, which is 39, is equal to my opposite side, 9, divided by my adjacent side. We'll call that GH. Remember, I want to make a ratio, so it's cross multiply and divide. So in our calculator, 9 times 1, divide by tan 39. Now remember, you don't ever have to add the times 1, because anything times 1 is just itself. So that becomes 9 divided by tan 39. And that gives me 11.1 is equal to GH. Now I'm looking for one more side here. And I'm going to, let's use a different trigonomic ratio instead of Pythagorean theorem. So let's use, if this is my hypotenuse, let's use sine. So sine says sine of my angle 39 is equal to my opposite side, which is 9, divided by my hypotenuse, which I don't know what it is. So I'm going to set it up as a ratio. I cross multiply, divide by what's left over. So again, in our calculator, 9 times 1 divided by sine 39 will give me that hypotenuse. So that is 14.3 is equal to my hypotenuse side. Again, hypotenuse should be the longest side, which it is. And those are the 3 missing sides and angles. There we go. So I'll get you to complete example B by yourself, and I will post the solutions. Good luck.